Throughout my career in aquaculture, I have witnessed firsthand how the oceans, covering more than 70% of our planet, shape our climate, feed billions, and sustain a breathtaking diversity of life. Yet, I have also seen a crisis unfolding beneath the surface, one that demands our urgent attention. For centuries, I have looked to the sea for both food and inspiration, just as so many before me have done. But today, I see wild fish stocks declining, habitats vanishing, and the delicate balance we once relied on under threat. The question I now ask is not whether we can take from the ocean, but whether we can do so responsibly, without destroying what we depend on. I have watched the world's appetite for seafood grow to unprecedented levels. As populations increase and diets evolve, the demand for protein from the sea continues to rise, placing immense pressure on marine ecosystems I have dedicated my life to understanding. Traditional fishing methods, which I once believed to be sustainable, now struggle to keep pace. Overfishing, habitat destruction, and pollution have left many species at risk, and I have seen communities that rely on the sea face an uncertain future. In response, I've turned to aquaculture, farming fish and other aquatic life, which has become the fastest-growing source of animal protein in the world. It offers hope, but I know it also brings new challenges and risks. I have seen how aquaculture can relieve pressure on wild fish stocks, restore habitats, and support livelihoods. But I have also witnessed the consequences of mismanagement, polluted waters, the spread of disease, and threats to the very environments we seek to protect. The stakes, as I see them, are high. The choices I make, and that we all make, will determine whether aquaculture becomes a force for renewal or a new source of harm. The science is clear to me. We must act with knowledge, care, and urgency. In this series, I will share my perspective on the environmental impacts of aquaculture, its promise, its pitfalls, and the path forward. I will examine the data, the stories, and introduce you to the people I have met who are working to shape a more sustainable future for our oceans. The journey ahead is complex, but I remain hopeful. With innovation, collaboration, and a commitment to stewardship, I believe we can ensure that the oceans continue to nourish life for generations to come. I invite you to join me as I seek answers to the urgent question of our oceans and discover how each of us can be part of the solution. My journey in aquaculture began not in a high-tech laboratory, but beside a quiet, muddy pond. It was there, in the stillness of nature, that I first glimpsed the intricate foundations of aquatic ecosystems. I remember watching those ponds, alive with fish, insects, plants, and countless microorganisms. Each played a part in a delicate, interconnected dance, a living lesson in how balance sustains the whole. Observing these natural systems taught me that every action has a reaction. I learned early on that the health of aquatic environments depends on maintaining a fragile equilibrium. As my studies deepened in academic settings, I saw how aquaculture could address global food security and sustainability. The idea of farming aquatic species emerged as a response to the growing needs of humanity. Yet, when I first encountered large-scale aquaculture, I realized its complexity. Industrial farms presented challenges and contradictions that defied easy answers. On the ground, I witnessed communities grappling with unintended consequences: salinized wells, vanished mangrove forests, and landscapes forever changed from what once supported diverse life. These experiences challenged my assumptions and revealed the true human and environmental costs of rapid expansion. Understanding these impacts, I realized, is essential for responsible progress in aquaculture. In my years working across Asia, I've witnessed firsthand how aquaculture's expansion has transformed both landscapes and livelihoods. I remember standing in the Philippines, gazing out at vast floating cities of bamboo cages, once open waters now bustling with the activity of modern fish farming. The scale is astonishing, and it's a testament to how quickly this industry has grown. Yet, I've also seen the costs of this transformation. Traditional fishing communities I've visited have found their access to open water restricted, their way of life challenged by the encroachment of aquaculture infrastructure. The changes are profound, and not everyone benefits equally. I've spoken with fishers whose navigation routes, used for generations, are now blocked, forcing them onto longer, riskier journeys. The tension between old and new ways of life is something I encounter again and again in my fieldwork, a recurring theme in the rise of aquaculture. The impact isn't limited to water. In many regions I've studied, aquaculture has reshaped the land itself, rice paddies and wetlands converted into ponds for fish and shrimp. The landscape changes before your eyes, and with it, the lives of those who depend on it. Economic pressures are a driving force behind these changes. I've met farmers who, faced with the promise of higher returns from aquaculture, have chosen to leave behind generations of rice cultivation. These are not easy decisions, and they lead to shifting, sometimes uncertain landscapes. In China, I've observed remarkable ingenuity. Terraced nurseries carved along reservoir coves, maximizing every bit of available land for aquaculture. It's a powerful example of human adaptability and enterprise in action. These experiences have taught me a vital lesson. The conflict between tradition and innovation is what drives change. But it also means we must constantly renegotiate how we use our most precious resources, land and water. The story of aquaculture is, at its heart, a story of adaptation and balance. In my years studying aquaculture, I have witnessed many environmental impacts, but none as visually dramatic or ecologically significant as the loss of mangrove forests. I remember walking along tropical coastlines where these forests once thrived, only to find them cleared at an alarming rate. Mangroves, I have learned, are vital ecosystems. They serve as nurseries for countless marine species, shield coastlines from storms, and filter pollutants from the water. Their intricate root systems support a web of life that, in my experience, is truly irreplaceable. Through aerial surveys and fieldwork, I have seen the stark transformation firsthand. Once green expanses have been replaced by aquaculture ponds and barren mudflats. The haunting images captured by satellites and researchers echo the rapid change I have observed on the ground. I have spoken with local communities who recall a time when mangroves lined the shore, providing food and livelihoods. Today, many of these areas are unrecognizable, and I have seen how traditional ways of life have been disrupted. The causes of mangrove loss, as my research has shown, are complex. While aquaculture expansion is a major driver, historical data reveal that clearing for agriculture, urban development and timber also played significant roles long before shrimp farming became widespread. In some regions I have studied, only a fraction of new aquaculture farms were built on primary mangrove land. This nuance is important to me as a scientist. It challenges the narrative that aquaculture alone is to blame and highlights the need for careful, evidence-based analysis. My work has taught me that mangrove loss is a shared responsibility. Urban expansion, logging, and conversion to rice fields or other crops have all contributed. Aquaculture is just one part of a much larger pattern of coastal change. Satellite data from 2008, which I have often referenced, estimated that aquaculture was responsible for the destruction of about 12% of Asia's mangrove cover. This is a significant figure, but it is only one part of a much broader and more troubling story of coastal ecosystem decline that I continue to study. In my years studying aquatic environments, I've learned that habitat loss isn't always dramatic. More often, it's a slow, silent transformation, one that unfolds beneath the surface, invisible to most, but unmistakable to those who look closely. In aquaculture, I've observed how waste, uneaten feed, fish excrement, settles to the bottom. Unlike on land, these byproducts are released directly into the environment, gradually accumulating on the seabed. Over time, I've watched the vibrant tapestry of life beneath the cages fade, replaced by a barren landscape. We call this the benthic halo, a zone where oxygen is depleted and diversity plummets. Bacteria thrive on this organic matter, consuming oxygen as they break it down. I've seen how this process creates dead zones, areas where most aquatic life simply cannot survive. The impact doesn't end at the farm. My research has shown that excess nutrients dissolve and drift, sometimes triggering algal blooms in lakes and coastal waters, a process we know as eutrophication. I've witnessed these blooms turn water into a soupy green, blocking sunlight, killing submerged plants, and altering entire ecosystems. Suspended solids from farms, I've found, can clog the gills of wild fish and smother sensitive habitats like seagrass beds and coral reefs. As organic matter decays, it can create anaerobic conditions. In my fieldwork, I've measured how bacteria produce toxic byproducts, ammonia, hydrogen sulfide, lethal to most aquatic life. This unseen transformation is profound and often irreversible. In my years working in aquaculture, I've come to see water as the true lifeblood of our industry. Yet it's a resource that's often taken for granted, until it runs short. I've witnessed firsthand how, in arid regions, fish ponds are sometimes repurposed as reservoirs, a clear sign of how water priorities shift in agriculture. From my perspective, the economics are undeniable. In many places I've visited, it's more profitable to allocate water to crops than to fish. This shift carries profound consequences for food production and the well-being of local communities I've worked with. I've been struck by just how much water aquaculture can consume. In some tropical systems I've studied, producing a single kilogram of fish can require hundreds of thousands of litres of water, a hidden cost that's easy to overlook but impossible to ignore. I've observed how evaporation and seepage act like a slow leak, steadily draining ponds. Over time, this constant loss can lower the local water table, impacting not just the farms I've managed, but also the surrounding communities. Through my research, I've seen how groundwater extraction for aquaculture can have dramatic effects. In some coastal regions I've visited, excessive pumping has caused the land to sink by meters, a sobering reminder of the risks we face. Another challenge I've encountered is salinization. As freshwater supplies dwindle, saltwater can intrude, contaminating wells and leaving once fertile fields barren. I've seen how this cascading effect can devastate rural livelihoods. I've watched as wells that once provided clean drinking water turned brackish, and rice paddies suffered. The impacts ripple through entire communities, reinforcing for me the deep interconnectedness of water, land, and food. In my years studying aquaculture, I've learned that its impact extends far beyond what meets the eye. The real threat often lies beneath the surface, chemicals and nutrients that silently flow from fish farms into rivers, lakes, and seas. I've stood by waters that look pristine, only to discover through my research that their chemistry tells a very different story. I often collect samples both upstream and downstream from aquaculture sites, searching for subtle changes. The results can be striking. Sudden spikes in nitrogen and phosphorus, silent drivers of ecological change that I've documented time and again. These nutrients act as fertilizer, fueling explosive growth of microscopic algae. In my fieldwork, I've witnessed this process, eutrophication, transforming vibrant waters into suffocating environments. It's a feast that can quickly turn deadly for aquatic life. When these algae blooms die, their decomposition consumes oxygen, stripping it from the water. I've seen fish and other creatures left gasping, and in some cases, entire zones rendered lifeless by this chain reaction. Through my research, I've found that the severity of these impacts depends on the environment's ability to absorb and process waste. A farm in a fast-flowing open sea may have little effect, but the same operation in a sheltered bay can trigger ecological disaster. Understanding these invisible changes has become central to my work. Only by seeing the full picture, chemical, biological, and human, can we hope to manage aquaculture's green tide and protect the waters that sustain us all. Throughout my career in aquaculture, I've witnessed how expertise is shaped by the vision of pioneering scientists, the rigor of data, and an unyielding curiosity. I remember standing in conference halls and collaborative forums where new ideas sparked, and the most influential voices, myself included, challenged the status quo, pushing our field forward. In these settings, I learned that data is more than just numbers. It is the bedrock of progress. The most respected among us defend our conclusions with evidence, transforming skepticism into meaningful dialogue and turning criticism into opportunities for growth. My own expertise was forged not just in laboratories, but in the field, immersed in the environments I sought to understand. The most impactful lessons came from gathering first-hand knowledge and building bridges between research and real-world application. I've seen that the solutions which endure are those that benefit both nature and people. My research only became truly meaningful when it led to positive change, restoring habitats, improving livelihoods, and ensuring the sustainability of aquatic resources. I quickly realized that no single discipline holds all the answers. The complexity of aquaculture's challenges demanded collaboration. Ecologists, economists, engineers, and local communities, myself included, working together to create holistic solutions. Through this process, I watched a shared language emerge. Our teams learned to translate across disciplines, building models that reflected the true complexity of aquatic systems and the societies that depend on them. For those who follow, I know the essential skills are clear: a strong foundation in the natural sciences, the ability to work across boundaries, and the courage to ask difficult questions. These are the building blocks of expertise I strive to pass on. But I've learned that expertise is not only technical, it is practical, learning to communicate clearly, to engage with communities, and to understand the economic and political realities that shape the future of aquaculture. These lessons have defined my journey, and I hope they inspire the next generation. The challenge before me, and all of us in aquaculture, is immense. How do I help feed a growing world without destroying the very ecosystems that sustain us? I see aquaculture standing at the crossroads of this question, its ripples touching every shore I've studied and cared for. For every warning sign I encounter, I also find hope. Nature's resilience, the ingenuity of farmers I've worked with, and the dedication of fellow scientists offer a path forward if we choose to walk it with care and intention. To me, sustainable aquaculture isn't a distant ideal. It's a living experiment, one I witness unfolding in real time, shaped by our choices and our willingness to learn from both failure and success. I believe the future of our oceans and the security of our food depend on the next generation of thinkers, doers, and leaders, those willing to ask hard questions and seek better answers, just as I strive to do in my own work. For me, responsibility means looking beyond the surface, considering the consequences of every action I take, and never losing sight of the bigger picture that connects us all. To nourish humanity while protecting the planet is not just a technical challenge for me, it is a moral one. I know the choices I make today will echo for generations to come. The story of aquaculture is still being written, and I am grateful to be part of it. I hope we can approach it with humility, curiosity, and resolve, so that the ripples we create lead to a thriving future for all.